Hey guys, what's up? Welcome back to the classroom. It's Mr. Low, and today we're going to discuss about chapter 9.2, rate. Alright, so for this lesson objective, let's take a look. We will learn about what are rates, alright, and later on we will learn about money exchanging, okay, exchange rates, alright, and last but not least, the difference between constant and average rates. So for this video, we are only going to discuss about the first item here, what are rates. We will look at some examples, and we will solve some problems. So before we continue the video, please go and pause your video and read the textbooks, page 47 and 63 if you have not already done so. Okay, please come back after that. Alright, if you have done so, let's move on. Okay, so let's look at what does rate mean. Okay, rate involves a comparison between two different quantities. Okay, two different quantities is usually expressed as something per something, such as 100 kilometers per hour, 10 words per minute, and $25 per day. What does this mean? Let's look at some examples that I can provide here, some very simple example. For instance, if I say that I'm eating grapes at the rate of 1 grape every 3 seconds, you see the word rate here. Okay, now, so we can express this sentence here as a mathematical equation, meaning the rate of eating grapes is 1 grape every 3 seconds. Okay, we express it as a fraction, 1 grape every 3 seconds. Okay, 1 grape per 3 seconds. Or I can say also equals to 1/3 grapes per second. It kind of doesn't make sense to say 1/3 grapes per second, but you get the idea. Alright, so this is the rate of me eating grapes. Then I can further ask questions by asking, okay, how many grapes can I eat in 9 seconds at the same rate? Or it sounds like, how many grapes can I eat in 9 seconds at the same speed? It sounds similar, but it's not exactly the same thing. So how do we do this? You can go think about it. Basically, the quick answer is you can take the rate of eating grapes multiply by 9 seconds to give me 3 grapes. All right, let's look at the next example. Okay, this one constant speed. Okay, I'm driving at the rate of 70 kilometers every hour. So I can express this rate as a fraction again, 70 kilometers every 1 hour. Or in short, 70 kilometers per hour. We use the word per in rate to express rate. Okay, so in this case, we do know that it is 70 kilometers per hour. There's a special name for that. Okay, we call that a speed. Right, 70 kilometers per hour is a speed. So in this case, pardon my handwriting, SPEED. All right, so in this case, speed is a special case for rate. All right, it's a special type of rate. All right, then I can further and ask question, how far can I drive in half an hour at the same rate or the same speed? So you do know that to find this, we just take 70 multiplied by half an hour to give me 35 kilometers. Okay, last example is a bit more interesting. Okay, so there is this spendthrift woman who spends $3,000 every month on fashion items. Well, this is not a good example, not a good role model for girls, right? So what is her spending rate? We can express her spending rate as a fraction, $3,000 every 1 month. So it's $3,000 per month. Okay, then I can further and ask question, how much money can she squander away in a year time at this rate? So how do we calculate this? Okay, if you're quick enough, you will tell me $3,000 times 12 months, right? Because you're spending $3,000 every month. In a year, there are 12 months. All right, so it gives you a rough idea of what rates are and what do I mean by rate being a comparison between two quantities. For the last example 3, the two quantities are money and time in dollars and in months. All right, so when it comes, you can see this kind of questions with units, you must be very sensitive about what type of units you should be using, or what type of units the question is asking. Okay, without further ado, let's go back to the notes. Okay, so we are done with this part. Okay, and my question to you is, rate is written as a fraction of two quantities as we have seen just now, but it's not exactly a ratio. Remember, we can express ratio in two forms, a dot dot b, a is to b form, or a over b, right? So rate is also written as a fraction, just like the second case here, but it is not exactly a ratio. Why? Answer: for ratio, we typically compare items or quantities that have the same unit. In this case, rate involves comparison between two different units. Okay, two different quantities, two different units, just like dollars and time. Okay, so in this case, it does not make sense to write this rate here as 25 is to 1 day. $25 is to 1 day. It does not make sense at all. Okay, so rate is like a ratio, but it's not exactly a ratio because of different quantities and different units. Okay, so for this class discussion question, you have to refer to page 49 of the question of the textbook. Okay, for this question, if you have not already done so, please pause the video and look at the question. All right, I hope everybody has read the question now. Okay, so let's take a look at an answer. Okay, so the cost of sending, part one asks, so there are many parts to this question. They're asking what are the cost of sending different types of envelopes, right? So if you look at the table, okay, a C5 envelope, okay, let me just open up the table. Oh, I don't agree with me, so sorry. Okay, so if you look at the question itself, okay, under the category of C5 envelope, there are there are a few weight items. First row is 20, up to 20 grams. Up to means from 0 grams to 20 grams. Anything above 20 grams, such as 21, 22 grams, we have to look at the next category, which is up to 40 grams. So from 21 all the way up to 40 grams is the second row. We refer to the second row. So C5 envelope weighing 21 grams, we have to look at the 40-gram category. Therefore, the answer is 37 cents. Next one, for non-standard envelope weighing 40 grams, non-standard envelopes, it is quite clear, right? Up to weighing 40 grams, we have to look at up to 40 grams. That's category, second row. Okay, and you get 60 cents. Right, C4, the weight 18 grams. If you look at the C4 category, okay, there's it is the same price, 60 cents, regardless of the weight of the envelope. So 60 cents, quite clear. Right, last one is a bit tricky here. Okay, we have a C6 envelope that weighs 43 grams. Now, if you look at under the C6 category, we have up to 20 grams, up to 40 grams, and up to 100 grams. Which one should we be looking at? Well, this envelope weighs 43 grams, which is above 40 grams. So no choice, we have to look at the category of up to 100 grams. But there is a problem there, which is the price there at that category, C6, up to 100 grams is blank. There is no number there. So what do we do? Okay, so no choice. We have to look across the 100-gram option, and we see that there is a special non-standard item up to 100 grams, and we have to choose that. Okay, so no choice. The answer is 90 cents. All right. Okay, so this is quite a special case because we are not exactly looking at a rate. We are not looking at how much does it cost to send every 1 gram or every 10 grams of parcel or envelope. In this case, this is by category, right? So it's not exactly the kind of examples that we are typically looking at for rates, but just take note, this is a very useful skill. If you need to send parcels, especially when you want to sell items on Carousel, you have to check the postage rate. How much does it cost for you to send your item, right, over to your buyer? All right, so let's look at the next question. Okay, question 1 says, okay, I have 2 different tins of chocolate milk powder. All right, so the first one I have is a 900-gram one, and I have also a 1.45 kilogram. So I've actually drawn it in the diagram below. I have a smaller tin can, 900 grams, that costs 12.50, and I have a bigger can of the same type of powder, 1.45 kilograms, that costs 17.90. Do take note that you see here there are 2 different units over here, grams and kilograms. Okay, we must bear in mind that we need to compare the same type of units. So over here I've written, okay, recall that 1 kilogram is 1000 grams. So later we need to do some conversion. And the question asks, which tin gives the better value for money? What does it mean? What does it mean by better value for money? Well, if you go to the market enough, right, you will know that it kind of means that, okay, you're paying lesser for the same amount of the item, in this case powder, or I can say we are paying lesser for every gram of powder. If you're not too sure what this means, I have an even simpler example. Usually if you go to a supermarket, you realize that, for example, a packet of chips, okay, if you buy more, they are likely to give you a discount for buying more. So for this example here, 1 packet of chips is $1, 2 packet is 180. So which one is more value for money? In this case, the answer is very clear. Buying 2 packs of the same chips gives you more value for money because you do a mental calculation at the back of your mind, you realize that it is 90 cents per pack if you buy 2 packs. So why do I need to do that? Why do I need to divide by 2 to give me 90 cents? Because I want to compare 1 pack to 1 pack over here. Right? So in this case, this is what I call the same basis for comparison. You want to compare, I have to compare 1 bag of chips to 1 pack of chips. Which one costs lesser? So in this case, my basis of comparison is 1 packet of chips. Alright, with this idea, let's go back to the question. I have 2 different sizes of chocolate milk powder, and we are asked which one gives better value for money. So from the experience of dealing with packets of chips, we know that we need a basis of comparison, the same basis of comparison. So what can I choose to be the same basis of comparison? Well, I can choose 1 gram of chocolate milk powder. So basically our task now here is to find out how much does it cost to buy for 1 gram of chocolate milk powder in the smaller can as compared to the larger can. The one that gives me a lesser cost every 1 gram of chocolate milk powder is the one that gives me better value for money. I think the concept should be quite simple for everyone. So let's go ahead and do the mathematics. Okay, so let me find out how much does it cost for 1 gram of powder for both cans. Okay, so how do I do it? For the 900-gram tin, okay, please take note of how I present the answer because you need to distinguish, you need to differentiate for the examiner. You need to tell your examiner which can are you referring to. Alright, so for the 900-gram tin, the cost of powder per gram or the cost per gram of powder, I simply take 1250, the cost, divide by 900 grams. That will give me about 13.89 cents per gram. So this is the cost every 1 gram of powder if I buy the smaller tin. Okay, I will do so for the 1.45 kg tin, but bear in mind that I have to convert kg to grams. So I multiply by 1,000. 1.45 times 1,000 is 1,450 grams. So same, I take the cost $17.9 divided by the mass of the weight of the milk powder. Okay, then I will get this quantity here about sorry, I think there's a typo here. Let me do the calculations again. 17.9 divided by 1450. That will give me 0.012. That is correct. I'm suspecting a calculation error because it shouldn't differ so much. Yes, sorry. The first one, I made a typo here. The first one should be 0.013. Let me move this away first. 0.013. So it's about 1.389 cents per gram, okay, of milk powder. Alright, let me just get rid of this highlight. Okay, highlight again. Right. So now I can compare between these two prices, which one is cheaper. Of course, the cheaper one will give me better value for money. So I'll write my concluding statement, which is very important. By comparison, the larger tin or the 1.45 kg tin is more value for money because it costs lesser every 1 gram of powder. Alright, even without doing a calculation, your experience should tell you that companies usually want you to buy more, so they give you a bit of discount for buying more. Right? So you can kind of check our answer here by common sense, because if your answer is the 900 gram tin, the smaller tin is more value for money, chances are something is wrong. Okay. Now, once you're done with this part, there is this problem solving tip over here. It asks us, just now we compare 1 gram of powder for both tins. That means our basis of comparison is 1 gram. That's why I say per gram over here. Can I choose per 100 grams instead of per gram? That means I compare what is the cost to buy 100 grams of the milk powder across both the cans. Can I do so? Answer is yes, definitely you can do so, and the numbers will be way easier to calculate. But you must be careful, how do I calculate per 100 grams? Okay, if you're not, you can take some time and go and work it out first. You can pause the video and try to work it out. The answer will be the same, as in your outcome will be the same. The larger tin is cheaper. If you're not too sure, we can discuss another time. Alright, and the big idea in this question is what we call proportionality. What does it mean? Okay, so for this example, proportionality means that I assume that for any can, right? Let's say for the smaller can, I'm paying $12.50 for 900 gram. Proportionality tells us that every gram in this powder is the same cost. This is why I can go ahead and calculate what is the cost per gram of powder simply by dividing by 900 grams. Okay, so proportionality tells us that within that same can, every gram costs the same. Okay, the word proportionality may mean different things for different question. Okay, when time comes, I will discuss this again. All right, let's move on to the next question. Okay, this example here is pretty difficult. Okay, reason. Okay, if you read the question, let's look at the question. So I have this piece of metal that's heated to very high temperature of 428 degrees Celsius. Before it's left to cool down, okay, the temperature will drop. Okay, the temperature of the metal falls at a rate of 23 degrees Celsius every minute for the first 3 minutes. Keyword here, for the first 3 minutes. Okay, after the first 3 minutes, what happens? It will start to drop at the rate of 15 degrees Celsius per minute for the next 15 minutes. That means for the first 3 minutes, the temperature is going to decrease or drop at a different rate as compared to the next 15 minutes. Which one drops at a higher rate? The first 3 minutes. Alright, because it's 23 degrees per minute, while 15 minutes after, for the next 15 minutes, after the third minute, it's going to drop slower at 15 degrees per minute. Okay, after 15 minutes, what happens? The rate is going to change again. This time it is 8 degrees Celsius every minute. Until when? For how long? The question didn't say, but until it reaches a room temperature of 35 degrees Celsius. Alright, that means after a total of 18 minutes, 3 minutes plus 15 minutes, after 18 minutes, the temperature is going to drop slower at a slower rate, 8 degrees Celsius per minute, until it's going to reach the room temperature of 25 degrees Celsius. Alright, okay, so part A. So here is this question is very tough because you have 3 different rates at the same time. You have to deal with 3 different rates for the same question. So no choice, we have to deal with the question part by part. That means we have to deal with it looking at the first 3 minutes. Then the next 15 minutes, we have to do another set of calculations. Then for the subsequent time, we have to do another set of calculations. So let's take a look. Okay. The question asks for part A, what is the temperature of the metal after 9 minutes? So 9 minutes, okay, over here, I will write equals to 3 minutes plus 6 minutes. Why do I do so? It's because the rate of temperature dropping is different for the first 3 minutes. Right, I'm highlighting green color in the as the same color as the how I highlight the question. And for the next 6 minutes, the rate is gonna be different. Okay, so let's check out how we're gonna do this. Okay, now again, please follow. First, try to mimic how I do my presentation, because you need to make your answers very, very clear to the examiner which part or which time are you referring to. Okay, so how do we do this? Okay, so at the start, when time is 0 minutes at the start, right, we know that the temperature is 428 degrees Celsius. Okay, this is when the metal just started cooling. Okay, so this one is given in the question. 3 minutes later, time equals to 3 minutes. Okay, 3 minutes later, the time is 3 minutes. Okay, what is the decrease in temperature? Well, at the rate of 23 degrees Celsius per minute, okay, the drop in temperature, I'll take the rate times the number of minutes. 23 times 3, that gives me 69 degrees Celsius. That is the drop in temperature in the first 3 minutes. So what is the temperature after 3 minutes? You take the initial 428 here minus the drop in temperature, which is 69, to give me 359 degrees Celsius. So this is the temperature at time equals to 3 minutes. Okay, at time equals 3 minutes, temperature is this. Now we're interested in finding, remember, what is the temperature after 9 minutes? After 9 minutes, yeah? Okay. So 3 minutes have passed. We want to find what is the temperature at 9 minutes. Then, no choice. We have to find the temperature 6 minutes later. Right, 6 minutes later, after 3 minutes, time is 9 minutes. And what is the decrease in temperature? We take the next rate, which is 15 degrees Celsius per minute, right? Remember, there's a different rate now, times 6 minutes. Be careful, it is 6 minutes, not 9 minutes. Because after 3 minutes, 6 minutes have passed to reach the time of 9 minutes. Okay, so 15 times 6 gives me 90 degrees Celsius. That is how much the temperature has dropped in the 6 minutes time. So the final temperature after 6 minutes, at a time of 9 minutes, is 359 minus 90, right, which is 629. Therefore, the time after 9 minutes is 629. So this is my concluding statement for this question. Remember that you must have it. All right, so when you look at this working here, the way that I do it is very clear. I break down into two different parts over here to work. Okay, because during these two times, these two intervals of time, the rate of temperature drop is different, 23 and 15. So I have no choice but to break them up into two different parts to work. Okay, once you understand this concept, part B is similar, just that it is way longer and more difficult. Let's look at the question. The question asks for the total time needed to reach the room temperature 25 degrees Celsius from the starting temperature of 428. Now, in case you're not too sure how the thing looks like, how the process looks like, I've drawn it over here. Okay, so at time is 0 minutes. Yeah, we know it's 4 to 8. 3 minutes later, plus 3 minutes later, at the time of 3 minutes, yeah, we have calculated in the previous part, is 359 degrees Celsius. This is the one I'm talking about. Okay, at time equals to 3 minutes, 359 degrees Celsius. And we are asked eventually, what is the time such that the temperature is now 25 degrees Celsius? Okay, we must remember that there is another rate in the question, that is the blue highlighted one. Okay, so after, from 18 minutes onwards, yep, it is 8 degrees Celsius per minute. So now we have three different parts to deal with: 0 to 3 minutes, 3 minutes to 18, and 18 minutes to unknown timing. Okay, so we have to do three different parts. Okay, let's take a look. From part A, again, your presentation of answers, please try to mimic how I do it. Okay, from part A, we start off from time equals to 3 minutes, because we already know that at 3 minutes time, the temperature is 359. So I'll just start here. I don't need to redo from 0 minutes. I'll just begin here. Now, 15 minutes later, now the rate of temperature drop has changed. Okay, 15 minutes later, time is 18 minutes. What is the drop in temperature? Well, the rate is 15 degrees Celsius per minute. I multiply by 15 minutes. Okay, that gives me 2 to 5. So the temperature after 15 minutes, at time equals to 18 minutes, at time is 18, the temperature is 134 degrees Celsius. Still very high as compared to 25 room temperature, 25 degrees Celsius. So we know that the metal has to cool even further. Okay, so this is when the third rate will come in. Okay, at 8 degrees Celsius per minute, 8 degrees Celsius per minute over here. Okay, so that is the rate from now onwards. But how long has passed? How much time has passed such that the temperature drops now to 25 degrees Celsius? That is the question. So no choice over here. I have to use algebra because I don't know how much time has passed. So let the number of minutes taken from the 18-minute mark, right, from 18 minutes and beyond, for the temperature to drop to 25 degrees Celsius. Let that number of minutes be x. So this is a very long definition for what x is. Okay, so from 18 minutes onwards, okay, after x number of minutes, what is the drop in temperature? Well, it's simply 8 times x, which is 8x degrees Celsius. So what's the final temperature? 134 minus 8x. Where do I get 134? From the previous part here. Okay, minus the drop in temperature in the x number of minutes. So after this after decreasing by this number of temperature, of degrees Celsius, sorry, what is the final temperature? Well, according to the question, it is nothing but room temperature, 25 degrees Celsius. So immediately we know that this equals to this, right? They're equal. So from the question, final temperature is 25 degrees Celsius. Therefore, 134 minus 8x equals to 25. From here, we are very familiar with how to do the algebra. You will arrive at a fraction, okay, a mixed fraction. X equals to 13 and 5 over 8 minutes. Okay, it's the unit is minutes over here. Alright, so what does, again, when you solve for x, when you arrive at a number for x, you must remember, you must come back to our definition. What do we define for x? Again, x is the number of minutes after 18 minutes. Okay, number of minutes taken after the 18 minutes mark. So what the question asks for, what is the final time when the temperature reaches 25 degrees Celsius? So total time needed, we take 18 minutes plus your x, which is 13 and 5 over 8. So arrive at your final answer, 31 and 5 over 8 minutes. This is the total amount of time from the start for the metal to cool from 400 over degrees Celsius to room temperature 25 degrees Celsius. Right, this question is extremely complicated because very clearly, if you look at the whole set of working for part B, we are breaking down the working into 3 different parts. One part here, okay, this is one part, 2 part, and the last part. Because each part there is a different rate. Alright, so I hope this is clear to you. We will further discuss the next part of the notes, which is money exchange rate. Right, this one is quite fun when you go for holiday. You have to care about what is the exchange rate of that country as compared to Singapore dollars. Alright, so thank you for watching. Alright, I'll see you then.